So let's go ahead and get kicked off and talk about Salesforce ISV DevOps. All right. So quickly, just a brief introduction to me. I've been focused on this weird world of Salesforce ISV DevOps for a little over the last decade. That started back in 2013 when I got tapped to join the Salesforce.org product delivery team, which was the team responsible for building out the infrastructure for nonprofit cloud and education cloud that Salesforce.org created. Those are all built as managed packages. We wound up running some of the largest scale ISV release operations on the platform. And the way we were able to do that is that we applied engineering principles and innovated a suite of open source tools called Cumulus Suite or Cumulus CI, you may have heard of. And now I left my role at Salesforce after 8.5 years and leading that team in April of 2022, so almost 2 years ago, to leave and start MuseLab, mainly in the interest of trying to help those in the community be able to leverage these tools in the process that we had built up at Salesforce.org. So I'm going to be talking about a lot of the lessons that we learned at .org and also the lessons that I've learned in working with ISVs in that time with MuseLab. All right, so quickly, just to introduce MuseLab, we're going to be talking a lot more about DevOps today, but who we are. We're really focused on this kind of new model of development, the product delivery model, which I'm going to be introducing and talking a lot about today. That's really what our focus is. We're not intending to be an SI. We're not intending to be a PDO. We actually would want to work with SIs and PDOs to help them improve their process. Our focus is specifically on composable development. So not only packages, but also extension packages are kind of our bread and butter. We sort of love those environments and those package architectures. A lot of what we do is based around open source, so we're really services heavy, especially right now. But we are looking at building out a product suite that we'll talk a little bit more about kind of in the session next week. That's really focused on building up an internal developer platform for Salesforce so that anybody can build on top of Salesforce with all the version control DevOps best practices in an easy way, compliance enforced and things like that. So really quickly, our service engagements that we do with ISVs or SI partners or with PDOs are generally structured as a 6 or a 12-month engagement, kind of based on the amount of work and the complexity of what's involved. And a lot of this is kind of strategy, coaching, mentoring. We do start with kind of the hands-on work of doing discovery and kind of building out a prototype of the process. But then it really shifts over to enabling the team, to enable the dev team, to enable release operations, and then finally to build out a product recipe that's repeatable that the entire organization can use. So we'll be talking about a lot of these details here, but I just kind of wanted to show this just to emphasize that what I'm talking about here is actually based on the experience of working with ISVs over the last 2 years and applying these principles on the outside of Salesforce.org. All right, so the agenda for today, it's fairly ambitious. We may not get through all of it, depending, and I definitely want to leave time for questions if there are questions, because I'd love this to be interactive. I'd love to hear what's on your mind too. So we're going to start off talking about DevOps principles. There's a lot written on DevOps principles that's really great. I'm not going to try to reinvent the wheel here. But I really want to focus more on how those principles apply to Salesforce ISVs specifically, because it's kind of a little bit of a different world. So then we're going to talk about the challenge, which I've come to name the DX silo effect. It's this consistent challenge that I find across every ISV that I talk to. And then we'll talk through the solution, the product delivery model, and D2X. And we'll define those a lot more as we go along. We'll then touch on what Salesforce Well Architected, which is a great bit of content about how to approach building on Salesforce in a way that is easy, adaptable, and trusted. And a big part of that is about the way that you approach the development process. They refer to it as the application lifecycle management. Similar terms with DevOps. So we'll look at what well-architected kind of guides us and sort of how the principles that we're talking about today align with well-architected. And then we will cover briefly DevOps process fundamentals for ISVs. So this is really high level. And then in part 2, next week, we'll go more in depth on the process and the tooling. So lots to get through. Let's continue on. The first thing, if you're here to find a tool that will fix all of your organizational problems, I'm sorry, you're not going to find it. I don't have that tool. That tool doesn't exist. DevOps principles and tools are not going to fix your problems, but trying to apply them will highlight where your problems are. And so I think a lot of the friction that teams experience when they're trying to implement DevOps are really highlighting kind of organizational or kind of philosophical challenges with the way that they're approaching thinking about their product. But you don't really see that. It seems like it's a DevOps problem. So we're going to talk about a lot of those kind of concepts today. So one of the guiding principles when I started at Salesforce.org back in 2013, I had prior to that worked in a lot of open source Python communities. And Trey Seaver from one of those communities had coined what was referred to as Seaver's Law of Software Engineering. And just to set a little bit of context, this may sound familiar to people working in the Salesforce ecosystem. You had a really rich framework where you wrote code. You maybe had the code in version control. But then you deployed that code into an instance, and there was lots of declarative content creation and configuration that was done in the instance that interacted with the code. So you encountered the situation where the same code behaved differently based on the persistent declarative configuration that was done in an individual instance. That caused Trey Seaver to coin Seaver's Law of Software Engineering. That persistence means always having to say you're sorry. It will always come back to bite you because you don't have it automated. It's not there along with your code and version control. And this is a really fundamental challenge and kind of a key concept that has guided me over the last decade. So that's, I guess we'll go back into the clouds here. You have ISVs work in kind of a weird world when it comes to DevOps. There's advantages and there's disadvantages when it comes to that. But ISVs work in these very kind of isolated packages, but we work in an environment in a world where all of our packages are flying through all these different cloud environments and orgs that have all this different configuration. It's this weird kind of world. It's not a solid foundation necessarily on which to build things in the way that DevOps is traditionally thought about. So how do we adapt that to our world? First, I'll jump back a little bit to general DevOps theory with this one quote from Atlassian. I've done a lot of reading about kind of general DevOps theory. And this one really kind of sums it up to me, what I think is important and a lot of what we're talking about today. At its essence, a DevOps culture involves closer collaboration and a shared responsibility between development and operations for the products they create and maintain. It's not about product builds it, tosses it over the wall to someone else, they figure out how to implement it. That's not DevOps. That's what DevOps was created as a culture in order to try to break down those silos. So when you apply these principles as ISVs, I think there's kind of 4 key things that if you do these successfully, you're going to be pretty well off. The first is break down those silos between engineering and operations, or dev and QA, or dev and solutions engineering. Break down those silos, bring those teams together, get them collaborating with each other. Make version control the source of truth for your product. We'll talk a lot more about that today. I talk with a lot of ISVs who believe that version control is the source of truth. And as we dig in, there's a number of reasons why it's actually not. The next is have a fully automated CI/CD pipelines in place so that all of your changes are kind of tested and released through a reliable process that is auditable. And finally, apply infrastructure as code concepts using scratch orgs. This is one of the really cool, unique capabilities that we have in Salesforce. So you might think, I have a DevOps problem, I need to go hire a DevOps engineer. I want to just kind of briefly call out, that's not likely to be successful. I'm not saying DevOps engineers are not valuable. I'm a DevOps engineer myself. But what I'm saying is just hiring a DevOps engineer is not going to fix the cultural problem that you have in the organization. You don't expect an engineer to solve deep-seated organizational problems that you have. And the thing that I find when I talk to most Salesforce ISVs that have a DevOps engineer or a DevOps engineering team is that when I talk to that team, I find out that the majority of the time that team is spending their time doing manual setup, manual release creation. They're not doing engineering. They're not engineering a process and a pipeline to do releases better. They're plugging the holes in the dam. They're doing all the manual work. They're essentially an operations role with a DevOps hat on it. And that's not fair to somebody that signs up to be a DevOps engineer. They wanted to be doing engineering work, and they're basically doing a bunch of admin work between works. The last thing that I see is the reality or the perception of excess DevOps capacity, because DevOps is not really understood by people if you kind of silo it off to the side. It becomes a dumping ground for work by other teams. So DevOps becomes the team that you go to get an org provision because you just want to poke around at some particular version of the product, rather than it being something about thinking about a platform of how you enable the organization to do that through self-service. All right, so there's some positive things. I actually think that I posted about this on LinkedIn about a month ago, that I think there's this missing positive story of DevOps in Salesforce. Like, we have this kind of defensive, like, no, it's not as bad as it is in other places. But there's some really cool things about the platform when it comes to DevOps that actually allow us to do things that you can't easily do on AWS or would be very expensive to do on AWS, for example. The first is Scratch orgs provide ephemeral infrastructure on demand. You get these for free. If I was building an AWS app and I needed to build a complex cluster, application to run my code in, and you told me that I could have 80 or 100 instances of those clusters running for free, that's pretty incredible. We should be really, really happy about that. The challenge is most people don't utilize Scratch orgs for the full potential that they have. Packages provide something like containerization or some similar containerization like functionality. It's a little weird, and there's a lot of things that you have to adapt around packaging. But ultimately, one of the things that I realized early on when I was trying to figure this out is that a package is ultimately just a zip file of metadata. Metadata or files are easy to version control. That's what version control is built for, is files. So, that is something that I think that we can, it's easy to get these things in version control and get them represented in version control. I point that out because it's a lot harder to represent an org in the org development model through version control. So we have some unique advantages as ISVs. Also, push upgrades are pretty awesome. You can get SaaS-like efficiencies without running any infrastructure by keeping everybody on the same version. Not a lot of ISVs do this, but it's a really cool capability. The Salesforce CLI provides a great tool belt for interacting with the platform. And I'm in this space, I'm passionate about this because I really do believe that ISV DevOps can lead the way for the entire ecosystem. If we make it easy for ISVs, because we have to, then we make it easy for anybody else to develop like an ISV, use packageable, composable development. But there's some constraints that we have to figure out how to work in. I often refer to the ISV DevOps world as kind of the Wild West or the Twilight Zone, sometimes at the same time. This is ChatGPT's attempt at drawing that. But it's both tricky in a technical sense, but I think it's also tricky in the sense that we kind of live in this weird corner of the Salesforce developer ecosystem. There's not a huge portion of the developer ecosystem where there's conversations around managed packages and kind of how to develop and release managed packages. So, it's more like the Wild West, I think, in that sense. But there's some things when people go to apply standard DevOps principles to Salesforce, even with ISV development, that makes it easier to implement these principles. There's some things you're never going to be able to do. You will never be able to do a blue-green deploy, where you stand up a new infrastructure, you deploy the code into it, you slowly migrate traffic over to it, you test it, and then you flip over and delete the old infrastructure. Not possible in our world. You really don't effectively have a way to roll back. You can only roll forward. And there's no ability to conduct tests in customer orgs. So the idea of testing after you do a deployment to make sure the deployment was successful and then being able to roll back is just not in the cards for us. You can't fully build and test in a container or a virtual machine. So a lot of DevOps tools kind of assume that you can just spin up a bunch more VMs and do all your testing there. There are limits on package version creation and scratch org creation. You can pay for increases on those limits. You can work with support, but when you hit them, they're kind of frustrating. In AWS, you'd just be hitting your spending limit. You just go ahead and increase it. And finally, metadata API coverage and platform packaging issues. There's spotty coverage in the metadata API. I hear people point this out all the time. Kind of on the flip side of that, there's a ton of coverage in the metadata API. There's a ton of things that are covered and that you can do with it. Now, ISVs kind of live in this world of building these isolated packages. And customers live in this world of really building out their particular org that might be made up of sets of those packages. So it's kind of a composition. But what we see missing here is kind of this bridge between the composable and repeatable products and solutions that can be built by ISVs and delivered to customers in a more rich way, and also that customers can use to build up pieces of their own environment. And MuseLab D2X, which we'll be talking about a lot more in the second session, but this is essentially our vision, and in an open source and hosted product vision to bring together and unify those worlds of package development and org development, so that you can build things that are kind of in between, that live in both worlds, but effectively deliver to orgs repeatedly. All right. That's enough theory. Let's talk about the fundamental problem that I find when I talk to most ISVs, or actually pretty much every ISV. And I've come to refer to this as the DX silo effect. And it has a particular impact on ISVs that are doing composable development. If you have solution development happening on top of your product, you have multiple products or extension packages, it really multiplies in impact. So the reason for the DX silo effect traces back to one fundamental problem, and it's a disconnect between the definition of the product. For most Salesforce ISVs, when you talk to them and you ask, do you have your package, do you have your product in version control, or is version control the source of truth for the product? They'll tell you, yes, version control is the source of truth for the package, for what goes into the package. And the dev team tends to think about the package as the product. But the organization doesn't really think about the package as the product. The customers don't think about the package as the product. So what do you do in that instance? Well, the package is just a piece of the overall product. The product is the thing that you can experience, that you can interact with, you can use, you can demo, you can test. To build the product, you've got to put the package into the org and then do a bunch of extra configuration on top of it. And most often that extra configuration is not represented through automation and version control. So that creates this impact on the overall team structure and the way that the team works. And remember that the goal of DevOps was to unify ops and dev. But the DX silo effect's impact on team structure is that essentially only the package source is version controlled. So it's not the source of truth for the product. The source of truth for the product is only when it gets installed into a persistent org where all that other configuration has been applied. And so you can see just in this diagram, everybody else in the business other than dev, who's working kind of in these isolated scratch orgs that don't really represent the product, everybody else is actually treating those orgs as the source of truth still. So you're building a package, but the product source of truth is still in those orgs. And there's a lot of impacts that that has. It means that when you talk about investing in DevOps, it seems like it's something that's just going to make your devs a little bit more efficient. And it sort of blocks you from being able to see the broader kind of strategic capabilities that you get from investing in DevOps and with your product. We'll talk a little bit more about that here in a minute. You can't shift left, so you encounter bugs real late in the process. They're expensive when they're expensive to fix, and a lot of people are involved in them, and it's really stressful. Scratch orgs are mostly only used by dev and maybe by test, usually not by test because there's so much configuration that has to be done manually to make a usable Scratch org for testing. And then every time that you go to create a support or training or demo org, or you have to rebuild your TSO, it requires extensive manual admin work to prepare orgs. You probably got long checklists, long post install docs for your customers and your partners, because every customer implementation also has to go through all that org setup expense and everything that they do. And so I've struggled over the years to try to figure out how to align KPIs and metrics to the kind of unique world that we work in and some of the parameters that we work in. And I spent some time over the weekend building up a cost calculator spreadsheet. I have a link to it here. I'll share this deck out, and I have a link on LinkedIn, or reach out to me. I'm happy to send it to you. But it's basically just a Google spreadsheet that you go plug in information about different types of orgs, who's creating them, how frequently they do. You project out your growth criteria as an organization. But I tried my best to kind of set it up where you have a scenario A and a scenario B of what current state and the potential future state could look like with investing in automation. And I've talked with a number of ISVs over the last couple of days, just to sort of vet my default numbers here. Generally, what the numbers represent is that about 34% of your staff time at a typical ISV is spent manually doing org setup work. So there's a lot of opportunity to optimize that. Your numbers may be different. That's why there's a calculator. You can plug in your own numbers and get your own comparisons. But it's nice because you can kind of game out these scenarios, because org setup costs are not tracked generally. They're just kind of they go to pad estimates. They seem like they're part of work, but they're hidden costs in your organization. Your staff spends a lot of time setting up orgs. Somebody does, even if you're not the one that's doing it. So the solution to that is this new model. I used to think it was an evolution beyond the package development model. I actually see it more as a middle ground between the package development model and the org development model, the product delivery model. And then D2X, which is kind of a tooling suite and repeatable process that allows you to implement it. So one of the most fundamental concepts in this entire presentation is this definition of the product delivery model. So rather than thinking about the product as a package version that gets generated as an artifact out of the development process. So dev's job is to generate the package version. Everybody else is to figure out how to implement that package version. The product delivery model redefines the product. And it says the product is an automation recipe that lives in version control that can be used throughout the product lifecycle to deliver complete product experiences to new or existing orgs. So in the product delivery model, anybody should be able to spin up a Scratch org out of a feature branch that has all the storytelling sample data set, be able to run through the demo stories in that of a new feature that's actively in development. So there's a couple of principles that are important here. The first is automation is part of the product. I had many discussions with our product managers at salesforce.org early on when we started kind of experimenting with this approach. And I would often hear, I need my developers working on features, not automation, not on delivery automation of how to deliver the feature. But in the product delivery model, that is part of the feature, how you deliver it, how you effectively get it out to customers. The other thing is that if you're doing work on a new feature and you don't have the automation in place so that it can be passed to QA and they could spin up an org and go start testing, that feature's not done yet. So you leave it in the branch and you continue working on it. And the last is you wind up investing a lot in building up this automation that's part of your product. So make sure that you do that in a way that is repeatable, that is composable, and portable so that you can reuse it, because there's a lot of places outside of just your CI builds or maybe developers running the CLI where that automation is useful to your product. All right, so when we talk about the product delivery model and we talk about product experience recipes, the goal of the product delivery model is to build out a comprehensive recipe to deliver a product into an org. And I tend to think about this from the perspective of kind of this 5-layer stack. And The first layer in the stack is dependencies. If you're building extension packages, you need to install other managed packages or unlock packages. If you're building, or maybe internal packages that you're building, you might have org shape dependencies, features, licenses, settings, and things like that you need to make sure you have in the org. Very few ISVs actually have this clearly defined and fully automated in their process. Where most ISVs focus on DevOps is on that next layer up, the package source itself. And that becomes tricky if you don't automate all of the dependencies. You're kind of building these things up as a stack. So you need to get the dependencies automated, the package source or the package install automated. Then you have any manipulation of unmanaged metadata that you need to do, changing profiles, assigning permission sets, maybe transforming some metadata, adding fields to a page layout, things like that. And then on top of that, any settings and configuration that you need to do in order to kind of configure the experience that you're trying to build of that particular package. And then on top of that, data sets, so that you can, when you run this recipe, you can log into the org and the personas that you talk about in UX during conversations, with product and UX and engineering and QA. Those personas are right there in the org and set up and ready to go. If you think through kind of all of these layers of your product, what does it take to kind of deliver all of these things? You'll get an idea. You'll actually kind of find this sort of hidden tech debt of missing automation that you've had in the product all along. So that's the product delivery model, is the kind of conceptual framework and theory to think about this. D2X is our open source and product vision here at MuseLab. D2X is short for the development to delivery experience. So rather than just thinking about the developer experience, let's take a more holistic view about the entire process of getting from dev to a customer. And D2X really is, it came out of the consulting engagements that I'm doing with my clients. I had one client with 15 managed packages that were a mix of 1GP and 2GP with extension hierarchies 5 layers deep. So D2X was largely built to enable the CI/CD process and everything that we were building up for each of their repositories to be easily repeatable and maintainable over time. It's open source. It's basically a mixture of Cumulus CI, of Salesforce CLI, and the best of GitHub to kind of pre-wire a whole process that you can run. So D2X is basically a pre-baked way of running a lot of the concepts in the process that we're talking about today. But we're not talking about the tooling as much today, so that'll be in the session next week. But when you go through this change, when you start applying the product delivery model, you start achieving where that recipe is the source of truth in version control for how somebody experiences the product. Now, all of your collaboration you don't have gatekeepers. Everything just goes through version control. If somebody wants an org, they have the ability to self-service provision the org. You remove bottlenecks and also the risk of state drift between orgs. If anybody here has ever had the same code works in QA1 but doesn't work in QA2, and now it's a scramble to figure out what's different between those orgs, that's state drift. That's also another instance of Seaver's law. Persistence means always having to say you're sorry. And not only is this just the product team and the product engineering team, but that team is now, is at the core of the broader business organization of how the product gets sold, how the product gets implemented, both through customer or through partners, directly by customers. But ultimately, this is not a siloed part of just the engineering organization. This is about how the overall business thinks about the product that it's creating. So when you make the transition over to doing this, there's a bunch of really cool things that you can do that were previously kind of impossible. You can use Scratchworks for everything. There's small asterisks here. You can't use it for large data volume testing. There's a couple of places, but pretty much everything you can use Scratchworks for. That means you don't have to maintain all those persistent orgs and do all that manual admin work on those orgs just to keep your process running. It also makes it easier to parallelize your work. You can shift left and fully test before you merge. So you don't need to merge to an integration branch to get to an integration environment so that you can test with a bunch of other features merged together too. You can test individually. You can regression test betas instead of having to create a production version. For 1GP packages especially, I think this is really, well, actually for 1GP or 2GP, this is really important. We went through this process at salesforce.org of switching from creating a production 1GP package version and then installing it into a test org so that we could test it, to using a Scratch org that was spun up on demand by the build, installed the latest version of the product, installed the latest beta or upgraded the product to the latest beta, and then we ran all the tests. And because we had the recipe to build up essentially the equivalent of that QA org the persistent QA org that we had before, but we had that in version control, we could run that test. We could do a complete regression test of our products using beta versions before we ever created a production version. But in order to do that, you have to be able to work in ephemeral, disposable environments because you can't work with betas otherwise. And then you can modularize your demo configurations, so you don't have to have one giant TSO that has every possible demo scenario. You can start splitting it up and building for different regions and different industries. You can breeze through compliance audits, which we'll talk about a little bit more here in a minute. You can drive down implementation costs for your products. It's now cheaper to implement your products. That could open up new markets to you, or new segments of the market that you were previously priced out of. And you can drive down maintenance costs for maintaining your process, and also maintenance costs for your customers and maintaining their products. So a lot beyond just making your developers more productive or preventing bugs from getting into production. Does that too. Those are really important. But I think these are kind of the things that a lot of people don't think about when they think about DevOps as much. All right, so I had this spreadsheet earlier about the org setup time cost. And again, you can go in and look in the spreadsheet, see my numbers and everything like that. If you disagree with any of them, I'd love to hear it. Actually, I want this to be a resource that we can use to try to understand this problem. But what I found when I kind of gamed this out of like, what happens when you automate, you start using Scratch orgs and new org creations instead of org updates and manual org admin. Ultimately, that number of staff time that's spent doing manual org setup work goes from about 34 to 32% down to about 12 to 14%. That's huge. And if that number is correct, I'd love to hear from all of you, about this as well. But if that number is correct, that's a huge unseen cost in your organization that exists because you're not investing in this automation. It's also pretty easy to make the ROI justification for making that investment. Now, another kind of quote about DevOps, as far as AWS defines it, what is DevOps? Under a DevOps model, development and operations teams are no longer siloed. So consider the two models here. The DX silo effect model on the left, which is what I find most ISVs working with. It's very obvious that dev is siloed from everyone else. Dev is working in version control, but version control is not the source of truth. That single test org is the source of truth at the center of it. In comparison, on the right, everything is centered around version control. Everyone is collaborating in whatever way they want to around version control. Anyone who needs to get an environment can just create one self-service in what they do. All right, so what does Salesforce Well Architected say about these kind of concepts? I have to say, I was really excited when I started really digging in and reading the guidance in Salesforce Well Architected, especially the application lifecycle management section. If you haven't read it, I highly recommend reading it. It's got some great content, but I want to highlight three kind of little snippets from it that sort of speak to some of the things we've been talking about. The first is, on org development, it has a pretty clear call to stop using org-based development. So those places internally where we're relying on org development model, where we're doing manual admin on an org in order to keep it up in a certain state versus automating that out of version control, well architected is calling on us to do better there. Consider also how you're setting your customers up for success and moving away from the org development model. The guidance of well architected isn't just to ISVs, this is guidance to all Salesforce customers. Are there things that you could be doing in how you're building your product that could set your customers better for success at being able to run source-based implementations of your products? And finally, make version control the source of truth for the product, not for the package, but for the product, for the overall thing that you're delivering. Those three things are the best things that you can do in order to get away from the org development model, because you're not tied to orgs anymore when you achieve that. The second is avoid overcrowded environments. So a single UAT org for a large development organization is an overcrowded environment. The problem is that features get mixed together and deployed. Untested features get mixed together and deployed in order to be tested. And you run into a challenge there of what if some of that work is good? Now you have to figure out how you promote just pieces of it. None of that process is really really happening through version control. If you're using version control, you're using branches, isolated and on-demand environments created from those branches, like the concepts of infrastructure as code that are used throughout the industry. Then you don't have those constraints. So isolate all your development work and test individually in separate orgs, and invest in self-service org provisioning so that anyone can create orgs from version control on demand. This is the best way to avoid overcrowded environments. Totally makes sense. If it's hard for you to create an org, or you know that creating an org is going to require you to go ask one of your other colleagues to do 4 hours of manual work to set it up for you, you might be more prone to just reuse an org. And that makes you more likely to be bit by Sieber's law. Something persisting in that org causes it to behave differently than what you expected, and that causes confusion. And the last from well architected, I apologize that quote is a little bit small to read, but really it's the guidance around decoupling environments from releases. I see a lot of people create this relationship between a branch and an environment. So you promote to the QA sandbox branch. That is kind of contrary to what this guidance is recommending. You should think about source control as creating releases. You don't merge into a branch in order to get into an environment. You merge into a branch in order to promote a release to a next stage of environments. So it's not about code for a particular environment, living at that one-to-one relationship of a branch to an environment. It's about branches representing releases and the release process, and making sure that you're modeling that. Prioritize optimization of new org creation over org maintenance and reuse. This, I think, is really critical, especially when it comes to, and it's the reason why scratch orgs and infrastructure as code are such powerful concepts. If you can make it easy for people to create a new org to start from scratch, rather than having to reuse, you're saving them so much time. You also are able to shift left and move that acceptance testing and that feedback to development much earlier to the development phase, rather than catching all the UAT feedback and everything after you're in the release cycle and you've got a committed release date when it's a scramble. All right, so I mentioned earlier, KPIs are really hard with this stuff, and trying to figure out how do you track this. I've tried to mentally map the DORA metrics, which you may have seen, to work in Salesforce and especially work as an ISV. And I just have this cognitive disconnect in getting them to map exactly. I think for ISVs, these three criteria are the ones that I think are really important to kind of focus on. Is first off, how long does it take you from a commit to being able to test as a namespace package? For a typical ISV, and I'm leaning towards a 1GP ISV here in this context, maybe 2 weeks. This might be 4 months if you're on a 4-month release cycle and you don't cut releases until the end for testing. With D2X, you're looking at about an hour because the build process is creating a package version for you on every commit. So you're getting that feedback so much faster in the process. The time to create a new development or a new test org or a new TSO or a new QA or any of those kind of environments, typical ISV, again, these numbers vary based on your particular product and situation, but typical ISV is probably 4 to 8 hours. With D2X, that's about 15 minutes and fully automated. And then the time to create and test a new package release, a day. If this includes a lot of manual regression testing, then potentially a lot longer than that for a typical ISV. But there's a lot of manual release operations work that's done in that time. Versus with D2X, you have an automated pipeline that runs that stuff through. So these comparisons, these changes are really stark when you kind of combine them all together. So the best data that I have on how to see the value and visualize the value of this approach was a case study from our first client engagement. And in that engagement, they were previously running on every feature branch commit a build that does a validate only deploy against a single static QA org. And it would also run the Apex tests, but that was all that it was doing. When we built out the full recipe and we were able to then in parallel run 2GP feature test builds where they were a 1GP package, but we were able to get a 2GP version of that package up and running and on every feature branch commit. So when we compared those two builds, the build of actually testing it as a package in a Scratch org versus doing validate only deploys against a single QA org, in 13 weeks, we found 235 instances where those 2GP feature test builds caught a failure that the validate only deploys didn't catch. So what does that mean? It means 235 times those builds caught an issue that didn't have to go to QA. So it wasn't something that dev thought that they were completed on. They had committed and they had pushed it up to the repo, but it caught it. And I did go through and filter out lots of duplicate errors and everything. I spent a lot of time with this data. It was pretty startling to me because if you think about what does it cost when a dev finds out while they're doing development that there's an issue with their code, which is almost nothing, versus if it gets promoted to QA and QA then sets up an environment, goes through and does the testing, finds issues and reports them back to dev. Or it happens later in the process where it's during release and regression testing, and now it's a scramble and there's a lot more visibility and a lot more hours of the organization's focus allocated towards that. Ultimately, you wind up with a pretty staggering number of hours that you save by catching these errors earlier. If you project that out from 13 weeks to a year, that's 7,520 hours that we projected that they saved. At $100 an hour, that's $750,000. Just in things that the automation found for you that saved you in time. Again, it's really hard to quantify these numbers because a lot of this lost time, a lot of the inefficiency isn't tracked in the way that we're tracking our work right now. All right. And actually, yeah, so one last, I want to briefly talk about process, and we're going to cover process in a lot more detail in part 2 of this. But thinking about process and release process, I hear the analogy of the release train a lot. I lived in New York City for 8 years, got to ride the subway all the time, and I really like the analogy of the release subway a lot better. What I mean by this is there's 3 key principles to the release subway. The first is regular frequent releases. Trains in New York City run every 30 minutes. If you miss the train, it's no big deal. There's another one coming through. Greatly reduces the stress of making sure you get on the right train. Same thing happens with the team if you have regular frequent releases. It also means that you're exercising your release muscle and know that it's something that you can do as you need. You want to make sure that you only put release ready features on the train. So if you have a feature that's missing documentation and you're not comfortable releasing it without that documentation, don't put it on the train. Make sure that it's release ready before it gets on the train. And the last one is the one thing that throws a curveball into the schedule of, that consistent schedule is when you get a sick passenger on the train. So make sure that you're fully testing everything as much as you possibly can before you put it on the train. There's always a risk after it gets on that something is detected there, but try to do as much testing as you can before you commit to putting something into a release. And I will skip through these slides, which we'll cover in more detail, but this is basically the development and QA process and then the release operations process that you set up and kind of run through your automated DevOps pipeline. We'll talk a lot more about how to set that up next week. But the key thing is kind of thinking about this conceptually is that every product, every solution, every implementation that you do can be run out of its own GitHub repository with its own process around it, or its own version control repository with its own fully automated process. So if you invest in making your CI/CD or your DevOps process repeatable across every product and every solution and every implementation you work on, then you wind up with this composable development delivery kind of product suite, where you have products at the core. You can build multiple different products and modules and extensions of them. You can have your solutions engineering team building out different solutions that are not just for demo, but can actually be used in implementations, even used in version control based implementations for a more sophisticated customer that wants to be able to apply this process of spinning up scratch orgs with all of their configuration pre-applied, so that they can build on top of what you've delivered to them. This to me is the dream. I don't know of anybody that's doing this 100% right now. So this is definitely a North Star vision, but I think it's really exciting, and I think this is what's possible with ISV DevOps that's really unique to some of the constraints and opportunities that we have with it. And all right, one last on process, and then we will go to questions. Is compliance for ISVs. I think this is something that a lot of ISVs, especially ISVs starting out, don't think through, and it comes back to bite you later. I had to live through the first of the audits that I went through as a FedRAMP audit at Salesforce.org of our process. It was remarkably easy, and I've spent a lot of time reflecting on that. The reason it was easy is because we had source control. What was in GitHub is the source of truth for our entire path to production for our product. There are a handful of exceptions to that, like a 1GP packaging org or a dev hub where we had to limit access down, but we were able to really lock down access to the path to production. So the biggest thing that an auditor wants to know is that an individual dev cannot author code and deploy that code into production or into customer environments. Keep in mind that includes your packaging org and who has access to your packaging org. That includes your dev hub and who has the ability to promote a package version in your dev hub if you're doing 2GP. And it includes your TSO. So everyone that has access to your TSO to go in and edit it is going to fall under audit compliance requirements. If you automate all your deploys to packaging, all your interactions with the dev hub, and all of your deploys and updates of the TSO using automation and version control, now all of those things come under the compliance regimes in version control and the features of GitHub for compliance checks that make it really easy to breeze through those audits. But if you don't have them, then you have to be able to prove that you have a manual process. The auditors want to see all the details of your enforcement in the history of your enforcement of that manual process. It's far easier to just show them in GitHub, here's my settings, here's how this is enforced, here's the audit log of when people turn this on and off. All right. And I will skip the part 2 preview so that we can get to questions, but we are going to talk about lots of fun things here, and there we go. So, John, I have not been monitoring the chat, so I have John Stahl here with me who has been. Okay. Well, you can, if you do have questions, we've got a couple of minutes here. You can put questions in the Google Meet chat. Oh, we have some raised hands. Hold on one sec. John, can you... Hold on. Sorry, it's been a while since I've done a webinar in Google Meet, so let me figure out how to call on people here real quick. Believe I saw Ted. Ted, I think to call on you, I would have to make you a contributor. So it might be best... Oh. Someone's telling me the chat is not available in the Google Meet. So... Well, you know what? I guess with that bit of a challenge, we might go ahead and wrap this for today. And then I will make sure that we have plenty of time set up for Q&A next week when we kind of go through and show applying this. Oh, wait, there is a Q&A. Okay. So there are two questions in the Q&A. There is a Q&A section. And it looks like the first question is from Julian Joseph. So I'll go ahead and take that. It is not a self-serving question, Julian, but he says that he wanted to know if I could expand on the idea of not hiring a DevOps engineer to solve all of your problems. Would it be worth it if you empower that DevOps engineer to influence your DevOps culture? Absolutely. I think really what you're looking for is more of a leader than an engineer necessarily. You can find those characteristics in both. But what I find is the holdup is not as much an engineering problem, it's a cultural shift problem in the organization. So if you go hire somebody that knows DevOps tools really well and you expect them to fix those organizational problems, you're setting them up for failure, which isn't good for you or for them. And so I think if you're maybe I'll characterize it as, if you really mean to hire a DevOps engineer, really monitor the percentage of their time that they're actually able to spend doing engineering work. If they're getting bogged down plugging the holes in the dam all the time and there's never time to invest in improving the process and the infrastructure around the process, then that's an indication of the problem that I'm talking about. Is that because DevOps isn't really well understood throughout the organization, you're less likely to, you're more likely to have other people presume that that person has capacity available to kind of handle whatever they need, or they're the right person to kind of go create an org or something like that. So Tony has a question. What does the top of that pillar data look like in source? Is this automated data scripts, templates, etc.? Yes. I will cover data a little bit in the next session. I might try to do another webinar later this year, more in depth on data and more in depth in some of these kind of tooling topics. But generally with Cumulus CI, that would be either static data that you've captured, relational data using the capture and load capability that Cumulus CI has built into it that interacts with either the REST API or the bulk API, or it could be done using Snowfakery. And Snowfakery is bundled with Cumulus CI. It is a relational data generator that when you use it with Cumulus CI, it generates relational data, and then Cumulus CI loads it into the org for you automatically. So what the recipe looks like in that sense is a YAML file, maybe some CSV files that are kind of pulled in and sourced into the recipe for static data. Or if you're capturing a relational data set using Cumulus CI's tools for that, what you would wind up with is right now a SQL file that's stored in version control, so you can see line by line diffs in the data set. But obviously not built for handling massive data sets or anything like that. And then Ted, the question about using alternative namespace packages as a way to start testing in a namespace package right away. I have a blog post that I wrote, I think sometime last year, that is titled 3 Approaches to Pre-Release Testing for ISVs. And that is one of the options that is considered and compared in there. Given that we have 2GP now, I actually don't like that option over the potential for 2GP feature test packages for a couple of reasons. The first is the risk of state drift. So if you spin up, if generally, I presume you're talking 1GP, where you would want an alternate namespace. And so what you're talking about is essentially maintaining a separate persistent packaging org that can have state drift from your main packaging org. So there's an introduction of risk when state drift occurs between those orgs, that you might be testing something that's not actually a reflection of how it would behave in the package. Thanks, John. The second reason that I don't like that approach is because you're effectively testing the code in a different namespace. So it's very easy to have something that is referencing a namespace in your test code in some post-install, kind of deployment or something like that, that works in the pre-release environment and then fails when you go into the production environment or into the release environment. In comparison, the 2GP feature test process that I was talking about a little bit earlier, and we'll go into a lot more detail about next week, that process creates an unverified 2GP package in the same namespace, or it creates a package version in the same namespace, and then sets a commit status in GitHub so that anybody can install that package version. Anybody that has access to the repository can install that package version. That means that any commit, you can get access to the same exact code running in a 2GP package, but in the same namespace, and with no risk of org state drift between them. So I like that approach a lot better. It's a lot easier to set up and maintain as well. And it seems more solid. I think the alternative namespace approach prior to that 2GP feature test thing was arguably the best that you could do. But I think 2GP feature testing is better, is far better in that sense. And I've been doing that approach for 4 years now, I want to say, and encountered surprisingly few differences and glitches between them. Almost all of them ultimately boiled down not to differences between 1GP and 2GP, but differences in how environments were being set up and something in the environment automation that was off. So, all right. Looks like we've got one more question, and so we'll go ahead and wrap with that. I know we are a little bit past the hour, so if you have to drop, feel free. Look forward to regrouping next week. And all right, so our last question is from Francisco. How would a non-developer create a release scratch org or beta scratch org? Would it be from GitHub running a flow, or is it better to have an app? Could it be Heroku that runs the flow for them? Yes. So there are two. So let me think about the right way of it. Everything exists today to enable somebody that's willing to use a command line interface to tap into and run that process with just a single command. I believed for a very long time, and I've come to understand that was incorrect, that everybody can learn the command line interface, and our job just needs to be able to build better command line interfaces. I know that's not right. And I know that, to achieve my goals of really enabling the citizen developer and getting declarative developers and code-based developers working together through version control in an effective way. I think the first thing that we need is these recipes to live in version control. And then once you have those recipes in version control, then it becomes a question of how do you expose them. So earlier I mentioned this phrase portable automation, which is one that is really kind of near and dear to me. Portable automation is, if you're going to invest in building that automation, build it in a framework or in whatever way that that you can build applications that take that automation and apply it in a particular user experience. So we did this at salesforce.org with an open source tool called MetaDeploy that's part of Cumulus Suite. We basically built a web application that ran the Cumulus CI automation that was defined in version control for our projects so that people could install our products through a web interface that would go through and not just install a single package like AppExchange does, but install multiple dependency packages, upgrade multiple packages, install a new package version, do all sorts of metadata manipulation, maybe create a community, load a sample data set, all from a point and click interface that they could do. So it's possible to build those user experiences. I will say I don't think those user experiences exist in the best way yet to tap into the power of these recipes when they exist in version control. That's one of the things I'm actively trying to build, and we'll talk more about that.